Good morning, good afternoon everybody. Welcome to DBO. Welcome back to DBO if you've been here before. This video is pretty exciting. We've had a lot of requests for this, so I decided to dive right in and make it happen. Before we get into this, guys, don't forget to like, comment, subscribe, smash the crap out of that like button. Give us some follows, tell people about us. I'm giving away a lot of free information here, and I very much listen to everything you guys have to say. So if you like what we're doing here, let us know what you want to see next. If you've got some kind of a crazy idea for a Frankenstein engine or a swap or something like that, this is all we do. So hit us up, let us know what you want to see, and we'll do it. So this is for you guys. Today, we're talking M20s, people. BMW M20, BMW M20. There's a lot of people out there that want to get more performance out of their M20s. They came in E30s, they came in E28s, they came in E34s. It's a very popular motor to use, and they were not very highly horsepower rated from the factory. So there's a lot of cool little tips and tricks that you can do to squeeze a lot more power out of these things. So that's what we're doing here, people. I'm going to show you exactly how to do this, and this is going to be a series, is going to be comprised of 2 engine builds. The first of which I'm going to show you how to build the really easy, really quick, really cheap one. The second one, we're going to build one that's a little bit bigger, revs a little bit higher, it's a little beefier, sounds nasty. We're shooting for about 200 of the wheels on the first build. On the second build, we're shooting for 300 of the wheels. This may or may not happen, but these are my goals. So the purpose of this video is I'm going to show you some differences here. I'm going to show you why you want to do this and show you how to get more performance out of your M20. This is a very common swap. So basically, the nutshell of it is that you take an M20 B27, so that's what this is. This is a 2.7 liter inline 6. BMW used these for quite some time. This is the baby 6, as they call it. This right here is an M20 B25. It is a 2.5 liter inline 6. All the architecture is identical. It's like a 5.3 LS1 versus a 4.8 LS1. Can't really tell a difference, but there is one. So what we're going to be doing is we're going to be taking the top end and all the electronics from our B25, and we're going to be putting them onto our B27. Kind of. I'm going to go a little bit more into depth about that here in a minute. First, let's get into some differences as to why you would want to do this. So this right here, like I said, is the M20 B27. Now, this was the economy motor, essentially. BMW designed this in the 80s to be their efficiency motor. It has much smaller runners on the intake manifold, first and foremost, so they do not flow as much. And the way you can tell that right off the bat without looking is you can see the spaces between these runners are far greater than the spaces on these runners. So this intake manifold actually flows a lot more, as well does the throttle bodies. So if you look at this, the bore size on the throttle body is very small on this versus a decent amount larger on the B25, okay? BMW also, in order to get the most efficiency out of these, this is genuinely like a diesel engine that runs on gas. I mean, it's very low revving, very torquey. The way that they achieved that is they tried to shave all of the parasitic losses that they could. So if you'll look in here, you'll see this engine only has 4 cam bearings on the head. So we've got one here, one here, one here, and one here. This actually allowed them to not put cam bearings on 2 of the places where the B25 does. So let's crack this open. So that reduces rotating losses, rotating drag. So on this one, you'll see we've got 1, 2, 3, 4, 5, 6, 7 cam bearings. And then over here, we've got 1, not 1, 2, not 1, 3, nothing there, and 4. So we've got 4 cam bearings versus, what did I say, 7? The head castings are more or less the same. The only difference is how large they are and the shape of the combustion chamber, which we'll get into when I disassemble it. The other thing that they did to reduce parasitic losses are the valve springs. The valve springs in these ETA motors are very, very, very soft. ETA, if you guys aren't familiar, is basically a slang term for the economy engine that the 528Es and the 325s and the 325Es came with. So very soft valve springs, less cam bearings. It has a larger stroke and a larger displacement, essentially, lower compression, it revs lower, and it is also on different engine management. So let's get into some of the things that we're going to need to do. And I will be reiterating all of these points, so don't feel like you need to memorize them. But if you do, take some notes, because there's going to be a lot of information here, guys. Differences here. So this again is the B27, the 2.7 liter economy engine. So we've already established the intake manifold has smaller runners. The throttle body has smaller runners. Less cam bearings, softer valve springs. The block itself is dimensionally identical. You can use the rotating assembly from either one of these and put them in either one of these. So exactly the same block. The difference is the throw of the crank is larger on the 2.7, the rod is thus shorter, and the piston is different. Now on the B25, it has a shorter throw, a longer rod, and again a different compression ratio and piston as a result. So one of the challenges that we're going to face here when we're doing this is going to be keeping the compression ratio at a workable rate. One of the problems that people run into is they'll just take all of the 2.5 stuff and they'll put it on the 2.7. Well, when you do this, it actually lowers the compression ratio from the already low 9.2 to 1. So that's pretty low. Usually motors with that low compression are turbo motors. These are not. These are low compression motors from the 80s. They were designed to be efficient and pass smog and all of that stuff. The way that we're going to do this is we're going to take the rotating assembly out of both of these engines, meaning the crank, rods, and pistons. We are going to take the 2.7 crank and rods, and we are going to take the 2.5 pistons and put them onto that and then put it back into our engine. So what we're going to be doing is using the E30 2.7 block. And for you guys at home, if you're doing a garage swap, a Frankenstein motor in your garage, whatever, you're going to want to use an E30 2.7 liter rather than an E28 2.7 liter. And an easy way to tell this, if you're getting the motor, luckily I have one to show you. This is an E28 motor right here. The very easy way to tell this right off the bat, two things. First of all, steel oil pan. Take a magnet and check it. You can use this oil pan in an E30 if you'd like to. Some people prefer it over the aluminum one because it's less prone to cracking. I don't believe in that. We'll see. We're going to do it anyway and give it a test. The other really easy way to tell if it has a harness on it is that the battery cables and all the relays and stuff actually goes towards the front of the car. In the E28, the battery sits right here. Versus in the E30, if we take a look at the harness, your relays actually sit over here, but your DME and everything comes off the back. So the easiest way to tell, like I said, is look for the battery terminals. If they're still on there and they're at the front of the motor, that's going to be an E28 motor. It's also going to have a steel pan on it. And the oiling rings, the oil control rings on the 2.7 E28 motor were not as good as the ones that they later developed for the E30. So if you're doing this, you want to make sure that you use the E30 blocks if you're going to be using 2.7 pistons. If you're not, it doesn't matter because you're moving the pistons over and the rings over. So if you're just going to keep it low compression and you're going to boost it, you're going to want to go with the E30 2.7 block. If you're switching over the pistons, the block is irrelevant. They're exactly the same. So don't worry about that. So an easy way to tell what Motronic system you're running, the early ones either came with one Motronic, okay, so actually they came with L-Jetronic, K-Jetronic, Motronic 1.0, or Motronic 1.1. We don't need to get into the specifics. You're going to need to use all the electronics off your 2.5 if this is for an E30. If it's not, shoot me an email. We'll answer questions, but we don't need to get that specific. But the easy way to tell is this right here is for your idle computer. The later Motronic 1.3 harnesses do not have an idle computer. The ECU controls it. I believe the E30 2.5 computers also have 3 rows on the DME plug right here. The 2.5 does not have this. This powers your coil. It does not have the idle computer. So if this is what your setup looks like, this is an early harness. Don't use this harness, okay? I don't have, unfortunately, the harness for this motor because somebody decided to steal it for another project, Chris. But that's okay. When we start installing it in the car, I will show you all the specifics. I'm going to show you how to wire it, what you need to do. As a review here, we're going to be using 2.7 rotating assembly in either one of the blocks, doesn't matter. This particular video right now is going to be the one that I'm showing you about how to do the budget version of this, okay? So I know you guys are going to hate on me for this, but we're going to be reusing bearings, okay? We're going to be reusing bearings. And so because of that, I would rather reuse all the bearings in the same motor. So we're going to be using the 2.7 block, and we're going to be moving everything over to this block. So basically the only thing left on this motor when we install it in the E30 that was a 2.7 is going to be the block itself, the crank, and the rods. Everything else is going to be coming from the 2.5, and that's including the oil pan, unless you just want to switch over the sensor, because the oil level sensor is different between both versions. So again, heads coming over, intake manifold coming over, throttle body coming over, and what a lot of people don't think about when they're doing this is you need all of the pulleys off the front as well, okay? And that's including the water pump pulley, all right? So water pump pulley has to move over. Your balancer needs to be moved over, and the reason for this is because of this little guy right here. This is where the crank sensor goes. Motronic 1.3 fires off of a front-mounted reluctor wheel. Okay, that's what this is called, the reluctor wheel. Basically, it's an impulse generator that tells the computer when to fire the spark and when to open the injectors. So we got to move balancer, water pump pulley, alternator. All the accessories need to be moved over. And depending on which car you're putting it into, if you're putting it into an early model, you're going to want to use the early 2.7, or it's an early model water pump, okay? And the difference is right here. So you'll see this one has 2 water necks. The later ones only have 1, so it'll just look like that. And the 2.5s actually came with both versions, so just make sure whatever car you have, if it was 87 or earlier, you're going to want to use, and I think there's actually some crossover in 1988 as well, but you're going to want to use your double neck filler style. So this is where your fill comes off of. So if your fill tank is on the passenger side of your car, you need the double neck, okay? If you are going to be putting this in a late model car, you want the single neck style, okay? And then the fill actually comes off of this hose that doesn't exist anymore, so we won't get into that. The fill actually runs off of a crossover hose that comes under here, goes to the thermostat housing, goes to the heater core, and then there's another pipe that comes out, and that's where your overflow's at. So if you have a square overflow tank on the driver's side, you're going to want to use the late model style. That is the late model. So, okay, enough of me flapping my gums. Let's get into some disassembly. So first things first, what we're going to want to do is break both of these motors down. So I've made tables on either side of these engines. We're going to start with the 2.7. We're going to break this all the way down. I'm going to show you guys some neat little things as we go. Differences, things to do, things not to do, things to look for. So yeah, let's get started. Okay, so we've got our head off of the engine, and now is a good time to show you the differences in piston design between the two engines. So this is the 2.7, again, that we disassembled first, and you'll notice that it has flat top reverse dish pistons in it, essentially. Closest to a flat top as you can get. It does have very small valve reliefs for the intake valves, but that is it. So they're dished flat top pistons. They're actually really good for boost. It's a very versatile piston. So if you guys are boosting a motor, this is a great piston to use. You can stick with this with the low compression ratio and just shove, like, I don't know, 25 psi down the throat of this thing, as long as you ARP it up and O-ring it and do all the fun stuff. We'll get into that in the second video, but this is kind of cool. I apologize for the noise, but if you want to see what a BMW engine looks like when it's rotating while it's running, this is what it looks like. Very loud, but very cool. So you'll notice the pistons are essentially in pairs here. So you've got one pair, one pair, one pair. So basically the firing order just goes like boom, 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 boom. Or basically when one piston is at top dead center, the other one is at bottom dead center. So when this one is intaking, this one is exhausting, and vice versa as you go down. All right, so we're getting to a pretty crucial point now, which is where we remove the entire rotating assembly out of this motor. So in order to do that, I'm going to flip it upside down, take the pan off, and I'm going to show you guys some things that you need to take in mind as you're disassembling. It is always a good idea to be as clean as you possibly can Always be organized, always be clean, label everything. If you're unplugging things, if you're not extraordinarily intimately familiar with these motors, label everything. Label the cylinders it came off of, label the plug it came off of, label everything. It's always good practice to do. So we've got this thing pretty much 90% of the way torn down. So at this point I'm going to flip it, take the pan off of it, and we're going to start working on getting this rotating assembly out, at which point we're going to switch to the 2.5. So, okay, so before we pull the rotating assembly, we want to make sure that we disassemble the oil pump spring and follower and all that. So first things first, 13 millimeter, remove the bracket right here. And these are almost always, unless you're dealing with a new motor, these are usually pretty disgusting and trashed. So like I always say, cleanliness is the most important thing that you can do when it comes to building engines. Cleanliness and consistency. So I'm going to try to clean as much of this nasty crap off as I can. If you guys are doing this out of the car, then I would clean and degrease and steam clean this whole motor before you even start to touch it, quite frankly. But since I did not do that, and we are going to be heat treating most of the stuff from this motor and cleaning it, then I'm not super worried about it, but we do want to make sure that none of this material gets into the oil pan and is allowed to be sucked up by the oil pump and run through the motor. And what we're going to want to do is pop this little guy off. Damn, that is on there. Jeez. You got any tricks for getting this sucker out? That was in.
No.
There we go.
Yeah, it was
maybe just
super seized.
whack it with a hammer.
Looks like it was just cocked in the bore a little bit.
Yep.
Straighten her up. That one is particularly stuck because usually.
Okay. So there we go. Got needle bearings, O-ring. I'll make sure you replace all these as you're disassembling. You guys saw me take that out. That's basically the oil pump drive. You don't really need to take it out if you don't want to, but I figured you guys would want to see everything that's involved in this motor. So now that we got it out, I'm going to flip it upside down, put a drain pan under here. This is actually a pretty handy thing to do so the oil can drain out right here and it won't get all over the floor. Swing. Okay, so at this stage in the game, we are now going to be removing the rotating assembly. Now this is a fairly involved process, to be honest with you. So what we're going to do is we're going to take all the pistons through the top and we're going to leave the crank in the motor. Since we are reusing this crank and we are reusing this block, I am not going to touch the main bearings. I am also going to get a lot of hate for what I'm about to say here, so let me get a disclaimer. When you are doing this, you should do it right. You should get new bearings for all of your rods. You should also get new rings, okay? I'm not going to do that because this is a budget stroker, and what's more budget than reusing parts that you shouldn't reuse? So, having said that, just know that this is not normal policy, okay? This is like, let's see what happens kind of thing. So, what we're going to do is we're going to be taking off 2 end cap bolts on 6 different rods. We're going to push the piston out through the top, through the bore. So if you're going to be a junkyard boy, then you're going to make sure that you not only organize what rod bearings came from what cylinders, but which one is the top and which one is the bottom, okay? So now the way that I like to do that is I like to draw a big rectangle, okay, and then do 6 lines throughout it, and then do 1 line across it. So as you pull it, you have upper and lower, and then so you do rod bearing, rod bearing, rod bearing, rod bearing. So I'll show you exactly how we're going to do that here in a second. Let me get a piece of cardboard or a pizza box or something we don't care about, and we're going to proceed to tear the rods out of this sucker. Okay, rod bearing time. So we've got uppers, we've got lowers. We've got 6 spaces, and we're just going to go accordingly. You can start 1 to 6, or you can start 6 to 1, doesn't matter. Just make sure you know which cylinders they came out of. So I'm going to start at number 6, and then they will proceed to number 1 accordingly. And this is a good way, as long as you got a safe place to put them, to keep your rod bearings organized. Another thing to keep attention to is the orientation, whether they go like this
Yep, and it's just got
or
one
like
box
this.
on it. Says
So I'm going to take these out and put them on the paper exactly how they came out. So the B7, you'll see that there's numbers. They're all oriented the same.
I appreciate it.
So
Thank you very much.
on this particular engine, and I don't know whether they changed, so I don't want to tell you guys the wrong thing, but it looks like this side is the exhaust side, I believe. Is it? Yeah, oil filters under the exhaust. So with the engine on its side, the letters should be oriented so that they are upright on the exhaust side. So that's how I'm doing it. So now we're going to go over here, and since these came out together, what I'm going to do is just set that right like it is. And then the fun part happens right here, where we get to push the rod and the piston out through the top of the bore. So a lot of times there's a little ridge at the end of the cylinder, and it can be tough to move it past. So if you need to push on the rod with something, make sure you do it with something soft, or you push somewhere that is not a bearing surface or a cylinder surface. So I'm going to be real careful here and push on the bolt hole. Okay. That didn't go well, but luckily we're not reusing that piston. Now this is the upper rod bearing. So that'll go right there. Yeah, don't do that. Have a friend help you. Don't do what I just did, because this would not be a piston I would want to use.
It's too bad you don't have any friends.
Good thing we're not using them. Yeah, too bad I got no friends. It's just me. All right, now we're gonna do the rest of them, and we'll get back to it when we're done. Okay, at this point we are pretty much done disassembling the 2.7. You can take it further than this if you want to do the main seals. I mean, that's really all that's left on this thing at this point. So if you want to take the crank out, you can. But at this point, I'm going to start disassembling the 2.5, and then once that's done, we're going to clean the ever-loving crap out of everything, and we're going to start reassembling. So basically, my goal is to get that engine all torn down, and then we're going to swap the 2.5 pistons onto these rods, which are 135 millimeters, at which point in time we will reinstall everything back into the block and see how long our worn rod bearings last when they're bouncing off the limiter. Okay, so if you're very lucky and you have friends with expensive tools like Aaron does, one of the things that's really good to do if you're not having your block machined and made to look perfect is you want to measure your cylinders for taper. There's two things you can measure for. Actually, there's a lot of things you can measure for, but two of the major ones are taper and if your bores are out of round. So what can happen, what we're going to measure for right now, is as that piston is coming up, there's what's called a rod angle, right? So if this is your cylinder wall right here. As that crankshaft comes around, it goes like that, and I don't have a rotational arm, so that doesn't work. But basically, the piston wants to move this way when it's at the bottom of the bore, and as it's being pushed up, it moves some more. So basically it puts forces on the inside and outside. So what will happen is your bore will actually ever so slightly look like this. So if that's the case, you want to make sure that you do not use that block, or if it is tapered, you get your block machined.
All this is a micrometer on a really fancy pedestal with adapters that you can set up to be in the range of the bore size that you have. So what you do is, usually I start at the top, these three will move, you press it in like that, and then you get it in, which luckily we're in good shape. And then what I usually do is start at the top and set the marker to 0, and then check to see how much it expands as it goes down. And you can do it, you pretty much want to set a 0 point at top or bottom and see how much it changes as you measure it between top and bottom. And I usually measure 3 to 4 points as I go down through, and you can rock it back and forth to kind of see where the measurement is. But currently at this point we are at 84 millimeters even. And then we can just keep working our way down. And we'll get about halfway down. I'll see where the biggest number is, or where the smallest number is, which we're actually in pretty good shape. still, the measurement at the top of that cylinder is the same as about the middle of that cylinder, which is 84 millimeters. We got a stock bore M20 here. We'll go all the way down to the bottom here and see what the smallest number we can get is. So again, this looks pretty good. This motor does not have very much taper at all in it, at least in cylinder 1. And that's what you're looking for. And eventually, it's only a couple thousandths of an inch. You can look up what BMW spec, it's a service spec of what it would be, and machine shops typically have that information as well. And that at a certain point, you want to have it bored over like 10 thousandths over, 20 thousandths over. And then if you do that though, you need to look at getting new pistons because your old pistons will no longer work. Correct.
Okay, so B25 manifold, large runner diameter. B27 manifold, small runner diameter. And Aaron, as I was about to do this comparison, actually pointed out something that is very good to mention. If you guys are doing the M20 stroker, but not changing out the pistons, you're going to want to run the B27 manifold. I hate to say it, but air velocities to the cylinders are extremely important, and a smaller intake runner size is a higher velocity. So if you're not going to change the piston, we would recommend running the B27 intake manifold. You can run the B25 throttle body on it, everything will work, and it should actually give you a little bit of bump and torque down low. So just a little bit of advice depending on what you're wanting to do. We are obviously changing the pistons, which you'll see here in a minute. So we're going to run the larger diameter manifold for more top end and better everything. I got the timing belt off of it. Let's see if there was anything to note. Not really. We got pretty lucky with this one. Actually, the motor looks pretty clean. I'm very pleased with the way that all of this is nice and golden. This means you know, it had regular oil changes and somebody actually cared for this car. I'll be honest with you, we didn't care for it when it was in our shop E30, but it should be a good motor. We definitely overheated this thing quite a few times, so this head is definitely getting decked. There's no doubt about that. All right, I'm gonna rip these manifolds off. We got our thermostat housing off. We didn't have bolts in it to begin with. Once I get the exhaust manifolds off, we'll go ahead and rip all the head bolts out and do some comparisons between combustion chamber design, piston design, and just kind of show you a bunch of more differences internally between the B25 motor and the B27 motor. So let's do some more adult Legoing. So disclaimer guys, this right here, you see all this junk? This is why you do not run tap water in your cooling system. This is what happens. The reason that you run distilled water and antifreeze only is because it does not rust the inside of your motor. So now we know that this head needs a hot tank pretty freaking bad because I can't even pull these head bolts out. These are all fully out and only a couple of them are coming off. And see that sucker real quick.
This part, but I got a really happy idea.
Look at this. Snapped one of these suckers right off. This thing puts out like almost 400 foot-pounds and it did not take it out. All right, as you can see, we got the head off. Now is a great time to check out some differences between the internals on the two motors. So this is the I engine, okay? And you'll notice that the pistons here, in comparison to the E pistons, are vastly different. So we've got flat tops with a nice quench area. These are domed pistons with a good sized quench area and valve reliefs on both sides. So you're actually gaining compression because of this piston when you run that other head. Also of note is the head differences. This head, this is the E head, the 2.7. You'll notice the combustion chamber has this flat area right here, and there's no change over here. It's just nice and smooth. Coming over here, you'll notice this area is not flat. there's actually a larger quench. The combustion chamber is completely differently shaped. This is almost like a hemispherical head. This combustion chamber in conjunction with that piston is what gives us our compression. So this is what we need. I'm gonna have this head cleaned and decked to the service limit of the head, which is right here. I will show you. So if you want to get a little cheater bump in compression, let's see, where's the service limit marks? Okay, right here. See this dome? Right here, let's get it nice and clean. So you'll notice there's like 10 or 15 thousandths between this surface and that casting mark right there. This casting mark is actually what tells you if you can machine this head more. So what I'm gonna have them do is just machine it down until that is flush. So that'll give us just a teeny tiny bump in compression. So I'm gonna have them take it to the service limit, and that's what we're gonna do. Guys, if you're doing a stroker build, I get that you wanna do it on a budget, but get your head decked. I'm not even gonna show you how to check it for being level because it needs to be done. You've got an iron block with an aluminum head. Anytime that happens, the head and the block cool at different rates. So when you take your cylinder head off, just get it machined. It's like 80 bucks. It's cheap. So you can also see, since we're looking at this one, how genuinely nasty this thing is. I mean, it is like, there's all kinds of scaling going on in here. We've got ports blocked with what looks like tree sap. Probably isn't, but you know, this head is nasty. So I'm gonna have him hot tank this thing while we're in there, and that way we won't have to worry about blowing head gaskets because of cooling problems and heating problems. Additionally, before I take it to the machine shop, it is very good practice because, especially with BMWs, the heads tend to crack. So you're going to want to check between your combustion chamber and your cooling passage. So get yourself a razor blade, clean it up, and look for any, I mean, they can be so tiny. It can look like a scratch, but you want to run your fingernail over it and then look to see if it goes through to anywhere. Luckily, I think we scored on this one, and it doesn't appear to have any cracks in it. At least not that I can see initially. So I think we're good to go. So that's exciting. On that note, I'm going to keep disassembling the short block, and then hopefully we'll be able to put together a long block here pretty soon. So this concludes our M20 stroker build video number 1. This is all the teardown stuff. Lots of info in here. Stay tuned for video number 2, which is going to be coming out soon. That's going to be all of the reassembly and all of the tricky engine building stuff. So stay tuned, and we'll see you guys on the flip side. Don't forget to like, comment, subscribe, tell your friends, tell your grandmother, tell your sister, tell your cousins in Mexico, you know, whatever. Tell everyone. Help us get the word out, guys. Thanks so much for watching. Have a great one.